Hello, in this video we show how to load 3D images, and this is CT image into PyTorch, create as tensors. So we know usually the colored image is 2 channel for height and width, but for example in medical data, CT images can be 3 channel. So in addition to the height and the width, there's also a depth channel. Depth, for example, will show different views from head to foot for the human body. And usually for 2 images, if we want to do image analysis in the PyTorch model, the sequence of the channel will be in, for example, this is the batch size, and C is for the channel, the RGB channel, and H for the height and width, W. So without these details, NCHW, this is a sequence of 4 dimension tensors for the batch size data loading into PyTorch model for updating the parameter. And for a 3D image, for example, only one image, we will get CDHW for this dimension, CD for one image. And we can, if we have multiple images for the CT 3D images, then the result will be NCDHW. So here is N is batch size and C is for the channel. Although from CT data image has no channel, but we have to add a dimension channel for the one size, and here depth and height and width. So next we will show how to implement this in PyTorch. So first we will load PyTorch and NumPy and load model for image IO. Then we can show where is this file for image, 3D image. So here in this location as DCM files 99. So this is only one 3D image for the long. Only one 3D image. So next we will load this we will load this image into a NumPy array. So we set this directory and load the type as DICOM. So for the CT data, DICOM is default. So we use VOL read. So this is for volumetric data 3D image. And we show this array shape. You can see this is one image, but shape is 99 with the depth 512 for height and 512 for the width. Although we cannot view this image from computer. Then we will transform this NumPy array using torch from NumPy and create into a tensor. So this volume is the tensor. And we can see this volume's shape. So this shape is same as in the NumPy array. But here, as we have seen, we have to add a channel. Although for the CT data there is no channel, but same as for the images, we have to add a channel. So we use unsqueeze function from torch, and we set 0 here. So 0 means the first channel. So the data information is the same, but now the shape is different. So now this one image has shape of this tensor is 1, 99, 512, and 512. So this is for the channel C, and this is for the depth for the 3D image, and this is height and this width. So this is for one image, and if we have multiple such kind of CT images, we can create a 5-dimensional tensor. So with n in the first, the channel second, and the depth, then height and width. So the final dimension, the shape will like NCDHW for the PyTorch model's input for a batch of 3D images. Thanks for watching.